today's video, I will be discussing 2022 PO Maths paper, and then the question number 14. I think it's question number 14. Each and every year gives us the question regarding differentiation. In part A, we have to draw a differential graph, and then in the part B, we are given with the question relating to your differential application, and they will be given different applications, and we are asked to find various applications with relation to differentiation. So let's begin with the question. They have given us a function f of x function f of x is 2x plus 3 divided by x plus 2 square then the condition that we have to know here is that the denominator is x plus 2, which means that x can never be equal to minus 2. X can never be equal to minus 2. Afterwards, the first step that we should follow is to differentiate this function f of x. So I'll differentiate this. F of x equals x plus 2 to the power 4. We have to double this power, that's power 4, and then after that, in the numerator we have to bring that same power, x plus 2 squared. The amount we doubled, that is x plus 2 squared, and then the function that is already here, the expression that's already here is 2x plus 3, and that of course we have to replace it in the same way as it does, minus, and then here 2x plus 3 we have to differentiate afterwards and keep this expression and differentiate this particular expression afterwards. So once you differentiate this function over here, it's just 2. It's 2, and here you have to first you should bring that expression with the power 2 and replace this function after differentiating it. You have to differentiate this particular function, that is 2, minus, and keep this function as it is, 2x plus 3, and then you need to differentiate this particular part, that is 2x plus 2. Right, so now we can simplify and see the common factor here. What is the common factor? It's x plus 2. X plus 2, and there's a 2 as well. Get that outside. X plus 2, and open a bigger bracket, and then you can see that x plus 2, take it out and simplify this, minus. What is remaining is 2x plus 3, and of the denominator you can see x plus 2 to the power 4, x plus 2 to the power 4, and afterwards just simplify this. We can put this with the denominator, that will become power 3, then there will be 2 here, x plus 2 minus 2x minus 3, and the denominator will be x plus 2 to the power 3, and after you simplify this you can get 2x minus 2x plus x, that's minus x, and minus 3 plus 2 is minus 1, divided by x plus 2 to the power 3. And you have f dash x. After differentiating fx, it's f dash x, and after that this is our f dash x. You can take a minus out, that is minus 2, x plus 1, and divided by x plus 2 to the power 3. This is our answer after once we have differentiated the expression they've given us. So now we'll move on to the question again. What they say is show that f dash x, the derivative of f of x is given by f dash x, that is minus 2x plus 1, x plus 2 to the power 3. And hence find the interval on which fx is increasing. Now we asked to find the intervals, and when proceeding with the question step by step, our next step is to say that this f of f dash x equals to 0. That's when we define the turning point. So we better write f dash x equals 0. That is when there is a turning point. Afterwards, this next step that we are to follow is to find the horizontal asymptote and the vertical asymptote. We better find out the vertical asymptote, which is written here. So we should write it separately and name that as vertical asymptote. So our vertical asymptote will be that is x equals minus 2. And what is the horizontal asymptote? There are two types of asymptotes. One is vertical asymptote, the other is horizontal asymptote. So now I'll be writing the vertical asymptote. I wrote the vertical asymptote. Next is the horizontal asymptote. When finding the horizontal asymptote, there's something essential to be learned. First of all, we need to find the limit of the function f of x. And the limit should be when if x goes to or x approaches to infinity. So once fx limit when x approaches to infinity, fx function, I better write it as 2x plus 3 divided by x plus 2 to the power 2. And here I can take x out. 2 plus 3 divided by x. I can take x squared out and take 1 plus 2 divided by x squared. So here we know that in fractional form the limit goes to 0, and here it's 1x cancels with another x. It's 2 divided by x. Here x is in the denominator. That in the sense this is a 0. This means it's a 0 because numerator is much more higher. Only if the numerator is very high, only it will reach n positive infinity. Because in this case, x is at the denominator, which means denominator part is very much larger compared to the numerator if the function approaches to 0. So whereas what we've understood right now is that this horizontal asymptote y approaches to 0. So y equals to 0 is the answer for the horizontal asymptote. Next, other than this, we need to find some more steps here. That is that we need to find the places where we can number line where we get x values. So that here it is, in this case it's there is a 0. There is a 0 here because there's a 2x. Once you take there's minus 2 as well because x plus 2 in the sense x equals to minus 2. There's a minus 2, and also there's 2x plus 3 equals to 0. Downwards I can see it equals to minus 3. So x equals minus 3 divided by 2. Minus 3 divided by 2 is minus 1.5. So this is minus 3 divided by 2. It is minus 2. So in this range I can say that I need to consider this for the f dash x, right? We need to consider the f dash x. Here x equals minus 1. X equals minus 1 and x equals minus 2. Do not consider minus 2 because it was not defined. This is not defined actually. That is what we call it as the vertical asymptote. That is not defined. Minus 2 is not defined. Hence, I can write minus 2 as well, and also minus 1. Minus 1 is the point on x. So I consider it's minus 1, and when the limit approaches from your right hand side towards the left hand side, and from your left hand side towards the right hand side, I can take the limits. So I will take the limits of the function when x approaches infinity, not infinity, when x approaches to minus 1 from its positive side. From its positive side, the function will be, function is negative infinity. Once the limit approaches from the left hand side towards the negative side of the function, that is towards the negative side in the sense it should approach in this way. So that is positive infinity, right? You'll be getting separate marks for each and every step that I write here. That's why I'm writing here. So next what we have to do is I'd better erase the board, or shall I continue like this? I find the turning point as well. Now that the turning point, now we are going to find the turning point, because there are x values when x equals to -1 and when x equals to -2. This point is not defined, as I mentioned above, not defined. That means y is already a 0. This is just a point, but not the turning point, right? But here, in case of the turning point, the only turning point is this one. So I need to find the y coordinate as well to find the point. There should be x and y coordinates. So here x is -1. So in order to find y, we need to substitute this x minus 1 in our fx function, not f dash. Okay, this is one important function, but we are going to substitute in our fx. Some students get the answers wrong because due to their like they know the theory very well, but suddenly by mistake they just substitute the answer they get here in f dash x unknowingly. Finally they realize that they've done a mistake, but here we should find it replacing x with the fx function. So once you substitute -1 to this x places, 2 into -1, going to -1 plus 3, -1 plus 2 is just 1, 1 square is 1, so no need of that one. My y value is -2 plus 3 is just 1. So what will be my coordinate? My coordinate, or the turning point, is -1, 1. That is my turning point. So we need to find whether this turning point is something like this or something like this, whether it's a maximum or a minimum. So to find whether it's a maximum or a minimum, we need to find the analysis of the table to find, so that we get the sign of f dash x, and from there we can come to a conclusion that this is a maximum or a minimum. So I'll have to erase the board now. Hope you guys understood. So I'll continue my question from here. First of all, I write the data points needed, the data we got from the previous part. Like f the fx that we were given is with which was 2x plus 3, x plus 2 squared, and my dash x. The f dash x I got. It's already given in the question, so you can verify the answer you got for f dash x is correct or not. You can verify once you are writing itself. When writing itself, so x plus 2 cube. Okay, so now, and the turning point I got is -1, 1, right? -1, 1. Yes, x minus 1. And now we'll find the sign of f dash x. My x values are x when x equals to -1 and when x equals to -2. I said this is not defined. Hence y is also 0. Here we got the y value as 1. Okay, so this is point we have to consider. Now I'll come to finding the sign of f dash x. This is actually should write this in a table format. Just write the ranges now. We'll get the ranges, like draw just, if you are unable to get the ranges specifically, it's better if you draw a number line and mark the x points. -2 here and -1. The range here is between -infinity and -2, and this range between -2 and -1, between -2 and x in between -2 and -1. Here x in between -1 and positive infinity. Right. Now let's check from on the right hand side or the extreme positive side, I have to substitute a positive value and substitute in this f dash x. Now you need to consider only f dash x, not fx. Only when finding this turning point only we had to consider fx. But in this case, when finding the sign for f dash x, you need to proceed on with the f dash x function. So here, since this is between, we should substitute a value in between -1 and positive infinity. So that's a trick here. Without having to substitute values, I'll use the trick after I find a specific sign for this side. Okay, for this side only I will use a certain value, like any value between -1 and positive infinity. I'll take 5, so I'll substitute 5 here. 5 plus 2 is something positive at the denominator, and then I substitute 5 here as well. It's something positive, but when multiplied by -2, it's something negative. So you get the negative divided by positive, that is a negative, right? That's a negative. So now, same, you can proceed the same step for this and this as well. But you see, I'll consider now this this part. I'll have to consider the range for this part, this value. Here the power is 1. Once you get odd numbers as the power, you can change the sign. The sign automatically changes to its opposite sign. So here is 1. This is the function that we are using here. So the power is odd. It's an odd number. 1 is odd. So this minus turns into positive automatically. You don't need to substitute values and get answers by simplification. Okay. So you can just write positive here. Here -2 in the sense this is the function we have to consider. 2 is here, so this is the function we have to consider. Here also the power is a 3. 3 is odd, hence this sign automatically shifts its sign to negative. So without having to substitute any value, you can get the signs very easily. So negative in the sense, what would be the gradient look like? What kind of a gradient will we get? So negative gradient is something like this. Positive gradient is something like this. Negative gradient is something like this. Right? So negative in the sense, in your marking schemes you can see that this negative in the sense the function, gradient of the function decreases. Since it's a positive here, gradient increases. Here because it's a negative, this one also decreases. So that's how we finalize this particular table and finding the function of f dash x. And afterwards I can come to conclusion whether this is a maximum or minimum. Like I said that the not defined point is in -2. This is the not defined point. So what is the defined point now? It's this one. This is the defined point. This is, you can see obviously that this is a maximum. So what kind of a maximum? This is the local maximum. Since you kept space to write with this a minimum or maximum, you can write it as a local maximum. Next we'll move on with the question, and hence find the intervals. We did find the intervals which fx is increasing and intervals which fx is decreasing. We also find the coordinates of the turning points of fx. Find the coordinates of the turning points of fx. We also found that already. This is the turning point for the fx function. Next it says, it is given that f double dash x. What do you mean by f double dash x? It is when the function f dash x, once it is derived for the second time. When the fx function is derived for the second time, then we express it as f double dash x. Once f dash x is differentiated again, then it would again be an f double dash x. So they have given us the f double dash x function. F double dash x, they represent it as 2 into 2x plus 1 and x plus 2 to the power 4. Here also x plus 2 in the sense this cannot be -2 because the denominator function, it cannot be a negative 2. Since then when it becomes a 0, this function does not exist. So Find the coordinates of the point of inflection. So same procedure we'll have to follow in here. And also remember to write our next step is that f double dash should be equal to 0 for this graph, for the functional gradient to exist. So once f double dash x equals to 0, this is not actually a gradient now because this is the second derivative. When moving on with this double second derivative differential products, we get not a stationary point nor a turning point. Instead, we get the point we call as an inflection point. This is the inflection point. Okay, so now we'll move on with the question. We'll figure out the x points now. Here x point is when 2x plus 1 equals to 0. Our x will be minus 1 divided by 2. Right? This. Again we have another x point, x minus 2. X equals minus 2 when x plus 2 equals to 0. So here since x not equal to minus 2 is not a defined point. It's a not defined point. Okay, so already y equals 0. Here also we cannot say that y equals 0 because this is a defined point. So again, as I mentioned you guys earlier, we have to look at the fx function and substitute this minus half. So when 2 into minus half plus 3 minus half plus 2 y. The y value you would be getting is 8 divided by 9. Once you simplify this, you'll be getting 8 divided by 9. So that is our inflection point. So the inflection point will be, inflection point is minus half. X coordinate is minus half, comma 8 divided by 9. So now also we should find whether it's a maximum or a minimum. For that also we'll have to move on with the sign graph, that is for sign of for f double dash x and represent the signs. So for sign of f double dash x, I write from here, sign of f double dash x. The points are represented in number line, and minus half, minus 2 and then minus half. Minus 2 and minus half. Those are the only 2 points. And here, yes. Now, with range between this side range, I'll write between minus infinity and minus 2. And the range between minus 2 and minus infinity. And the range between positive infinity and minus half. Okay, these are the ranges in the table format. And now I'll find a specific value and substitute here and identify whether I'll be getting a positive or a negative. Positive or a negative. Downwards, by looking at the powers, I can get an estimated idea whether it would be a negative or a positive. So for this particular column only, I will substitute a certain value. So here also I substitute like positive 10, any value I substitute 10. For 10 I'll be getting a positive at the denominator. Positive at the denominator, and the numerator is also positive because there aren't any negative values to be seen, so that's also positive. Positive divided by positive is always a positive. So now I look at the powers. I will be looking at the powers for this part. Minus half is available in this part. So here it's odd value. 1 is odd, hence the sign will reverse. I'll get the opposite sign, that is negative. And now we'll consider the minus to exist in this particular function, in this particular part, you see here. So here you can see that the power is 4. 4 is an even number, hence this sign will not change. It will be the same sign as negative. So this is our sign pattern, negative, negative, positive. Here since this is negative, we will be getting, since these are inflection points, the inflection point will be kind of like this. It will decrease and then this will increase. Okay, negative. It will decrease, whereas the positive one will increase. You don't need to draw it. In your marking schemes, we are not asked to draw the pattern or draw the graph or shape for the inflection points, but for the gradient, finding the gradient or the turning points, you should be able to draw how these gradients vary. So here, we'll just write what is happening here. So here, since it's a negative, we call it a down concave. It is down concavity or down concave. Here also down concave. Here, since it's a positive, we call it up concave. Up concavity or concave. So this is our sign table for the inflection points. Now we can see that our undefined point is our not defined point. So you must not consider this -2 part. Instead, consider this part. So here there is an inflection point. So there is a negative sign as well as a positive sign. Hence, you'll be getting inflection point like this. When drawing the graph, you'll be able to see a position where it looks like something like this, and this particular point. When drawing the graph, you'll be able to see clearly. So here, I can see that this indeed is an inflection point. I verified the fact that it's an inflection. And now, all the conditions that you are when you are asked to draw the graph are all completed here. So now what you are to be doing right now is to draw the graph only. So using all these data or data points, you can draw the graph. So here I will just draw the sketch of the graph, but please keep in mind to draw the graph very clearly in a separate paper and mark the horizontal and vertical asymptotes, mark the turning points, mark each and every point you got here and downwards. And remember not to I'll just draw and show you guys how to draw the graph. So I'll erase this particular part only. This is how I draw the graph, because since I'm drawing in this board, you'll see some defects in my drawing, so ignore them. Name the x and y axis and write the asymptote, vertical asymptote which we got before part. I wrote that vertical asymptote, I wrote it as x equals -2. So -2 is somewhere here, so my vertical asymptote, draw a dotted line. Horizontal asymptote was 0, so horizontal asymptote lies in here, in the 0 axis itself. So now my vertical and horizontal asymptotes are done, and then I should mark my turning, my points. One point I got is this one, -1, -1. -1 is somewhere here. 1 is towards the positive side in y-axis. So this is 1 point and it's a maximum. So I'll just draw a hat sign like this so that I can easily understand that it's somehow going to be a maximum after completing. So I just draw it like that. And then there was another point we got. That is when x equals -2. I said that the y is automatically becomes a 0 because it's not defined point. So here -2, 0. -2, 0 lies here. So that's another point. Then there is another point we got for the inflection point, that is -half, 8/9. -half lies somewhere here and 8/9 lies somewhere below 1. It lies somewhere below 1. It will be somewhere here, 8/9. So it's going to be somewhere here, 8/9. Okay. So that is the inflection point. This is my inflection point. Okay. This is my turning point. So now we'll see this side away from towards the negative side from the -2. It's a negative gradient. It says decreasing. What does a negative gradient look like? Positive gradients usually we draw it like this, gradually increasing. Negative gradients come like this. So my graph will be something like this. because it's a negative here. Now between minus 2 and minus half. Minus 2 and minus 1 will be an increment. It will be an increment. So I draw that increment coming from here, here, increasing, and then it gradually decreases. Between minus 1 and minus 2, I drew it as the increment. So remember not to touch the dotted line because it's the asymptote, it's the vertical asymptote. So then between minus 1 and infinity, between minus 1 and infinity is going to decrease again. So that decrement will get reduced like this, like this, like this. Never touch this x-axis. Just draw as if it's coming down systematically. My one looks a bit uglier. So this should be the actual shape of the graph you drew. So don't exceed this too much. Okay. So this is our flow. Right. So the inflection point is right here. Turning point is right here. You can write the points here as x and y. Write this point as well. And that means this particular point and this particular point. Right. So that's all for today. I think next they are asking us. This is now that we have completed the whole drawing the graph. We have completed the whole part, and now what they ask is state the smallest value of k for which fx is 1-to-1 function. Since the smallest value of k for which fx is 1-to-1 is when k equals minus 1. When k equals minus 1. K equals minus 1. That of course you get only 5 marks. Major theories for drawing the graphs I explained before. And that's all for part A. In the next video I will bring the part B, that is the application part.